Now that we have a mathematical representation for the picture of a cat, where a picture of a cat is a tuple, and in this tuple you have X representing or storing the features, and Y which represents the label, whether it's a cat or a not or a non-cat. And we then have the data set. The data set, because it's called a data set because it's actually storing the data that we have. Now what we want to do is that we want to think about the Pythonic representation. What concepts are there in Python that we can use to convert all of this? We want to convert column vector to something in Python that would be storing the same things, like the intensities of the color. We would need something, an integer in Python that would store the label of our cat. The label represents, the label keeps you, whether it's a cat or not a cat, like you label something, you label this as this, label that as that. So Y is or a label here because it's going to label our picture, whether it's a cat or not a cat. We have this tuple. We would need something in Python to have the same characteristics as a tuple in mathematics. Then we would need something in Python again to have to store our data set. So let's talk about that. In Python, we can take the help of array. We have something called array, or we have something called list in Python to store the intensities of the color. But professionally, but now the standard has come where now the developers are using a library called NumPy, and this NumPy library gives you n-dimensional array, and this n-dimensional array is way faster than a simple array in Python, and programmers use this library NumPy, and this library gives you ND array function. For those who don't know, who's just learning machine learning or just binary classification and don't know what a Python or like, they would have some sense because they would be hearing, okay, we're going to need some kind of programming to do this. So for those who don't know what a library is, it's just a big box, and a big box that if you're going to open, is going to have tools in it. So I'm just using a fancy word. This big box is a library, and in this big box you're going to find tools, and those tools are going to help you. They're going to help you to do stuff. Okay, integer in mathematics, you have integers, whole numbers, and in Python you're going to need just a simple variable to depict that. Normally the programmers again use the same name Y, and they just save the value in it, like 1 or 0. 1 represents, in our case, a cat, and 0 is going to represent non-cat. So if your column vector saves the picture, the features of the cat, then a programmer would store 1 in Y. And if your column vector is storing what a picture, the features of other than cat, then the programmer would store 0. Now we're going to talk about the tuple. In Python, you have the same thing, tuple, but again, you may find different libraries that are fast to store tuples. Okay, so in Python, you have tuple that can help you to store array, because you're going to be storing array and just an integer in Python. Now we're going to talk about the data set, because in the end, like I said, you're gonna be writing programs. You need something depiction of your mathematical notation, but that you're gonna need that because eventually you're gonna be performing operations on that thing. And we have what? We have matrices. We have matrices in Python too. How would you represent a data set? You would actually create a matrix. You would actually create a matrix, and you would name it just like you would name any other thing. So you would create a matrix, and in this matrix, what you're going to do is that you're going to just store the feature vectors, of cat and the feature vectors of dog. There you go. That's it. This means you're going to store the feature vectors of your data point. So you're going to take the tuple, you're going to take the first part, and you're going to store that part in matrix. So again, for tuple for dog, you're going to store this part in it. That's it. The X part, the part that stores the features. And now out of these features, you're gonna create a matrix. Now that we are talking about matrix, we have to talk about the dimensions of this matrix. This is really important. So to do that, I'm gonna have to just actually discard everything for now, or I can erase everything for now, because we're gonna talk about the dimensions and I'm gonna need space to do that. Let's take an example. And let's say that we have a feature vector X, and this feature vector X again stores the values for the features of cat. That's my first feature vector, and this feature vector might be representing the features of the cat. I have another feature vector, and this might represent the features of some other animal. I don't want to be talking about cats and dogs. So this one, I don't know, maybe some horse over here, but other than a cat. Now that you have these features, what you're gonna do next is that you're gonna create a matrix, and please keep that in mind. This is a capital X, so you're gonna create a matrix. Now I'm gonna ask you, how many rows would be there in your matrix? So the number of rows would be the number of rows of your feature vector, because you're actually going to store these feature vectors in your matrix. So what I'm going to do is that I'm just going to write the numbers over here: 100, 200, 50, and 30. And my next feature vector is 101, 201, 51, and 31. Now I'm going to ask you, how many columns would our matrix X would have? The number of columns would be the number of feature vectors we have in hand. In general, the number of columns would be the number of data points we would have in our data set. In our case, we were talking about tuple for cat, tuple for dog, and let's say we had hundreds of examples, hundreds of pictures, then we would have hundreds of feature vectors, right, for each of our picture. And then to store all of these features, we would create a matrix, and that matrix would be storing hundreds of columns representing our pictures. But in our case, we just have a data set consists of 2 pictures, therefore 2 matrices of two feature vectors, and then a matrix having 2 columns. So I'm going to close this matrix now. Now if you notice that is a data, that is our data for the features. The other thing is, if you notice, we are missing again something. What we are missing? We are missing the Y. We are missing the Y for the cat and the dog, because this tuple of cat would have what? X, Y. Let me call X1, Y1 to differentiate it. This tuple for dog would have X2, Y2. So we did put X1 in here. We did put X2 in here. But now we are missing Y1, Y2. So what we're going to do is that we're going to create a separate matrix Y. And we're going to store the values for Y in that matrix. So how many rows would be there in the matrix Y? The rows would be just 1 row, because this time, if you notice Y1, let's say Y1 would not be a feature vector. It would just be a number, a single number. For cat, it would be 1. It would be 1. And for dog, it would be 0. That's it. That's a single row. And how many columns would be there? The same. How many examples there are? How many data points there are in our data set? So we would have 1 row, but 2 columns. So now I want to talk about the dimensions. What would be the dimension for our matrix X? The matrix X would have, the dimensions of our matrix would then be, how many rows are there? There are 1, 2, 3, 4 rows by 2 columns. So we would say it is a dimension from the space. The dimensions of our space are 4 rows and 2 columns. And what about the Y? What would be the dimension for the matrix Y? So Y would belong to the dimension where we have just 1 row and 2 columns. And in general, what would you say? What would you say in general for some other data set? In general, what would be the criteria? You would say, okay, X would be from some space, real number space, where what would you have is, you would have nx rows. Here nx, if you remember, nx was the number of features in our column vector. Number of features in our column vector. Okay. So to give you an example, to review how many features are there, 1, 2, 3, 4. So nx2 is 4 and nx1 is also 4. nx1 is also 4. So nx would be the features, the number of features in our column vector, and how many columns would be there? Nx by m. M is number of data points in our data, or instances, examples in our data. There you go. So in our case, this data over here had 2 data points, 2 data points. So therefore, we had 2 over here.